Hi, everybody, and you're very welcome to the March episode of our Earth Observation GIS webinar, supported by Women in Spatial Eurogi Irish chapter. And we have two great speakers here for you today. But before we get into the talks, I just want to let you know, and maybe you can pass the message on to people who might be interested. We're going to have a kind of a special early career webinar next month, which is the 7th of April, I believe. And we'll have a few people talking about early, sort of different aspects, I suppose, of early career stuff. Somebody from the recruitment side, somebody from the engineering side, and somebody from the more sort of scientific side. And we hope you can join us for that. And maybe if you're connected with students or people who are kind of close to graduating, either just before or just after, you can spread the message. Would be great. So today we have two speakers as usual, and we're going to start off with Joanna Chrachol, who's from the new Tailte Éireann, and we're very excited to have a talk from Tailte Éireann, Joanna. So I'll let you take the floor and introduce yourself. Thank you.
Good afternoon. My name is Joanna Chrachol. So I'm working as a Jenny mentioned in a Tailte surveying department. I'm a manager of the remote sensing and surveying manager in the remote sensing analytics section. So yeah, I just wanted to we're working on the land cover and change detection project currently on the second iteration of the land cover, but I just wanted to go back to give you a short introduction of my path. It was kind of curved path. So I just finished my education in college as an in environmental engineering bachelor and master in Poland, and then before I finished bachelor, the first stage of the environmental engineering, I started geodesic cartography as well. So the bachelor's step, and then after I finished that, I started to work in the mayor's office in geodesy department, and then my path changed a little bit because I moved to Ireland, moved up to Ireland. So, and then I started to work and learn language in retail department. So I was working as a food safety officer leader, and so it took me about 11 years so to get out from the section. So I just I started to feel unfulfilled, because I've done so much degrees, and so I just needed something more. So I applied to RSI, Ordnance Survey of Ireland, but I got a feedback that I don't have recent experience. So I decided to go for another master in geocomputation in Maynooth University in Ireland. So in Maynooth, 30 kilometers away from the 35, around from Dublin. So I completed that, and then I got a job. I was offered a job in the Murphy Surveys as a surveyor, so a kind of processor. And then I just then I got an offer to work on the bursary project between Maynooth University and OSI. So the project was the land cover, the land cover database using high resolution satellite and aerial imageries. So, and then during that project, I got offered to be an OSI staff. So that's my path. It took me a little bit long just to be what I wanted to be, and but it was worth it. And actually, and then I just have to mention, just not for compassion, but just to motivate people. So like 3 years ago during COVID, I got sick, breast cancer, but just wanted to let you know that it's not, you can't stop. You just think positive, go forward, like whatever your dreams are. So just a positive thought at the end of my introduction. That's my input in this.
Great. Would you want to go ahead and share your technical presentation? Thanks. So the meeting will be recorded and you'll be able to see it on our YouTube channel. It's usually up within a few days after the webinar.
Oh, okay, that's brilliant. I just that's my first screen, actually slide. So I just my topic is eCognition software and its usage in change detection and uncover processes, and then the change down. It won't work.
Okay. Do you want to maybe put it in slide mode?
Okay, where is this? Oh, over here.
Yeah,
down.
there you go.
Slideshow. Oh, okay.
That's it. Yeah.
Is that okay? Yeah, it's perfect. So yeah, the change detection is is the process where we identify the differences between object and during the different times, seasons, and under different conditions. So our aim of our project was to automatically detect changes using our vector database, which is Prime2, and or our orthophotographs. And then our aim was to capture new buildings and extensions, which are the roofed and wall structures. So new buildings are kind of the objects with no border and no relation to existing buildings, and extensions is kind of opposite, like attached to the buildings currently existing buildings. So the conditions we were taken, like there was the high data greater than 2 meters, then NDVI normalized difference vegetation index below 0, and then area, we captured buildings and extensions greater than 100 square meters. So that's the data sources were, as I mentioned, it's a series 3 as imagery. The series 3 data were captured between 2016 and 2018. And then Prime2 vector database, and then high data. So the software we used for pre-processing was ArcGIS Pro, and the software used for the processing stage was the framework eCognition, and then FME we used for post-processing step. So this is our kind of block. So as as you can see, we have in here 29 blocks in here. I don't know. Can you see my mouse? So can you see my mouse, Jenny? No. But yeah, there is 29 blocks, and then we focus on one every time at one block. So you see that, for example, this block, like block 16, it's not great quality because it was flown during different days and different conditions. So we received seam lines from the ortho department, and I combined these seam lines into 38 seam line styles according to the spectral values and quality of the orthos, and then we focused on that. And so we moving to the processing step. We created within eCognition. I created the workspace and then the project. We loaded data, as you can see, is the raster data and the vector data. And then on the view settings, we received these kind of all the vector layers and image layers. And here on this, we used the rule set to split the full block according to the subsets I created before, like 38. And the results I received was 38 blocks in here. So then a kind of sub projects. So every single, so then we worked. We were able to work on the separate project. We needed to split the block by the seam lines because it was too heavy for the software, so it was crashing, like from simultaneous, kind of like from time to time. So it was too heavy. Data were too heavy. So that's the way how eCognition looks with the data implemented and loaded, and the sub projects created. The rule set is in the process tree, and the window we have this and the kind of the boundary of the subset, like in red, and then we have an object information table, which is very valuable for putting informations into and run this rules. I will mention that in a second. So yeah, that's the rule based, and the process was kind of rule based. So we had a pre-processing where we created all the layers, like normal, the kind of water index, vegetation index, soil index. So they were helping us to distinguish different objects. And then we moved, so after running the indexes, we got this small window with all the layers. And then we run a segmentation extract buildings section. So we just focused. We used Prime2, so just wanted to kind of mask out all the data we have in our vector database. So just to not look on it, we wanted to focus on the other areas, like not being covered by the Prime2, if you know what I mean. So we've done that, and that's the output. That's the segmentation, and that's the merged Prime2 objects like ways, rivers, and the buildings are visible here. So, and then we move forward in here to capture more data, specifically according to Func and Form ID, Func ID and Form ID, according to the Prime2s. So, and then we merged them, and then we got this kind of it's more specified objects, segments. And then I run the find elevated objects. We were looking for the segments which had elevation greater than 2 meters. So you can see, like, kind of it's pretty hard, but as you can see it, kind of blue, light blue areas. It's like it might be forestry, might be building, yeah. So we run these sections, like find water unmapped as well. We needed to find water unmapped, which means that water which didn't exist in the Prime2. So, and then demolish buildings. And that's actually the classification. We moved from this section to classification when we moved, find unmapped water, and then demolish buildings, vegetation, and forestry as well, whatever was over the height, like 7 meters, or yeah, or more. Then we run the find shadow, because it was kind of problematic, the shadow, so it needed to be specified kind of I supported myself with the object information table, and then clicked, I investigated on the imagery how what segment could be, and like kind of I needed to learn of the image first, and then I was looking at the image, and then like the segment was a little bit high, and I knew that it's supposed to be that the height was pretty higher, and it's supposed to be like vegetation or forestry, but it wasn't. But it was the shadow, so we needed. You have to learn about image before you go into the rule and run rule sets and write rules. So, and then we move to the find. We got this after merging all the shadows, vegetation in the previous sections. That's the woodlands. So different kind of woodlands, and you needed to distinguish them as well. And so and then I moved towards finding new buildings. And here I used the high data as well for the finding new buildings, customer brightness as well, which was very handy, kind of helpful, and ratio of green as well. So, and then I moved here to the refinement of the new buildings. So and I specified that whatever like elevated but new building, it's a new class I created, which is kind of greater than, which is greater or equal to 100 square meters, and is not related to the new building that will be extension. And if it's related, kind of it's close related border to the existing buildings, it's extension. If it's not, that's new building. So, and then we move forward to the extracting and exporting data. So we exported data as that's the actually example of the new building captured. In the sim line there was only one, yeah. And then how it looks in the ArcGIS is like this. It's not properly kind of, yeah, it's in yellow. That's we exported data as a point and a polygon just for the needs of the other department working on the data exported. So, and then I just wanted to show you how it looks like, or what it looks like for the whole the block. So there is a number of the subsets, and then we have in the blue are the new extensions, and then new polygon, new buildings are in pink, and the tables, attribute tables, are kind of showing that new buildings was for this block, and block size is kind of 50 by 70k. Kilometers, so they're humongous. And then there is kind of number of the new buildings in here, over 700, and over 900 extensions. Yeah, so that's shortly. Yeah, I know it's I could talk about eCognition and Ruth a little bit more, but we're time limited. But yeah, I just wanted to move forward to land cover as well, because I think it's worth it to talk about it. So that was this. We're pretty proud of it, of this project. And so that's kind of a sample. And it was a collaborative project between EPA and Tailte and us, like Ordnance Survey, but currently Tailte Éireann. And so we had, and we worked, yes, with a number of the the stakeholders. So we had a third-party data. We used them, and there was as well the person from EPA who created kind of rule set for us. So, and we tested it, and we changed it like according to our needs as well. We kind of communicate with that person just to be able to improve it and to fit our purpose. So, and that's just a short introduction on like what's the land cover. And because we worked on the land cover, not land use. So land cover is the object which is presented. There are the objects physically presented on the Earth surface, and land use is like the way we use it. So it's kind of, yeah, confusing. And I just wanted to kind of clarified. So like, for example, here, land cover is improved grassland, and then in here, and then the land use is the pasture or silage cutting, or the same with the here marine water, which was captured, I think, from the prime two, and then is the land use is the fishing, swimming, and sailing. So that's the land use. So yeah, making land cover is that it was a process. So of the number of the tasks. So we've classified the we captured actually we classified 39 classes, a kind of classify. Yeah. Our classification system has a 36 classes at the moment. It's a level 2 classes. So it's kind of more, that was the previously the kind of, we can compare and see the difference of the more specified classes. And then it's, oh no, it's not, yeah, actually, yeah, that's the sources, and then consultation of the different stakeholders. Yeah, so, and here is the data collection. So we needed we used our Prime2, we used our high data, and we used our ortho photographs as well. But, and then, as I said, we used third-party data like all the forestries and agricultural departments, LEPIS data. So, and we worked on the 29 blocks. There was, I know it's 30, but that's 29 blocks. We started from the 30, but we moved forward to 29, and then we split it. Actually, production schedule was that we moved from the southeast. That's the bioregion, biogeographical regions. So according to the landscape and stuff like, yeah. So it was confirmed. I wasn't at the time in the project, but it was confirmed that it's gonna be the best idea to work on it with the stakeholders and collaborative APA as well. So it's so the mapping method, we used a similar approach to the one I adapted in the change detection. So we had kind of that's kind of giving you idea how it looks like. So that's the second block, and that these are the seam lines of covering this this block. So there is like up to between 15 to 20 kind of seam lines. So yeah, the data used, we stack data according to this. So, and data used are kind of visible here as well. And and then that's the output what we got from the process. Then in the post-processing section, we had raw output data, but you can see it's not kind of a straight line. It's kind of some of the objects were kind of slivers. We needed to remove them, so we used FME in the post-processing section, so stage, and then you can see it's kind of it's neat and smooth, the boundaries of the objects. So, and we provide a validation in collaboration with different organizations. So there was 56 validators. We took samples, over 22,000 samples. So there was we provided a number of the presentations in terms of the key identification processes, and so there was this, we in the process of the creating the working on the classification, we use random forest process. So, and then we captured, we had 80% of the samples for classification, and then 20 for the trainings, and then 20 for the validation process. So there was over 28,000 assessments done, and there was it was very intense time. And the geometric accuracy and thematic accuracy, as you can see, is kind of geometrically it's like these are the classes, 36 classes, and we confirmed after discussions with the stakeholders and collaborative organization, we agreed that we take as a proper kind of that we agreed that 75% of the accuracy is the minimum what we want to achieve. So that's the target. 75. So you can see that geometrically, it's perfectly our achievement is great. But in here, some of the classes we need to be looked after a little bit more in the second iterations, which we're actually going to do now. So so that's our next goal. But then here, comparing the coring land cover and our current land cover map, so comparing like 2018 year, it's like we can see that and we made some, actually that's so we're a little bit below with the grasslands and peatlands. The peatlands were kind of challenging class to capture as well. But we need to work on that, and the rest of the classes were given us satisfactory result. So these are the stats for it. So, and the answering the question why we need a new land cover map. So with the land cover map as the first iteration is that's it. That's the coring land cover from 2018. That's and then where is the next one? Sorry, I just like and here. So these are the classes we received, and that's our kind of in detailed land cover. So it's very, very usable at the moment, I'd say. And just to see difference as well and the same area. And so you can see that there is a, like on this window is like kind of 3 classes, and in here we have specified a little bit like more than the tree lines, the hedgerows, the scrubs. Yeah, yeah. And here is the similar where the cultivated and improved grasslands. Yes, and I would like to thank you. And that's actually the land cover in full size of the full Republic of Ireland. And in here it's kind of a little bit zoomed in and into some area on the top and shown in ArcGIS. And that's the kind of change detection. I wanted to put some screen grabs on the as the final, so to capture the buildings according to the rule sets. Yeah, so I just wanted to thank you, and just if you have any questions, just let me know. Thank you.
Thank you so much, Joanna. I'm afraid my laptop just I had to log out and shut it down and restart it again. So I'm sorry I couldn't answer your question there. I couldn't access the controls. So if anybody has a question, can you just unmute yourself and come on in, or you can put a question in the chat. Yeah, Lorraine, come on in there.
Hi, Joanna. Thank you so much.
Hi,
that
Lorraine.
was really interesting, and the volume of work is clearly massive.
Yes.
Did you have any overlap with Ordnance Survey Northern Ireland on the project, the project that they are doing on land cover?
No, unfortunately not, yeah.
They've gone through a process in the last number of years, and they're probably really at the same stage as yourself. So I think the overlap would be very, very interesting, particularly for border areas as well.
Yeah, I agree. Yeah,
I can reach out to the contacts and
oh yeah. I'll pass it on to my manager. Yeah, it's great.
Great.
Thank you.
Yeah.
Thanks, Lorraine.
Thanks.
And Sita, did you have something?
Yeah, thank you so much, Joanna, for the presentation. I selfishly love the detailness of the project because we have one in-house project exactly kind of fits with the same. And so one of my colleagues, Michael O'Connor, he's working full-time on this. I have a couple of questions there. So I know you said you had we have a lot of problem with shadow, and from your presentation you were saying it was just manual kind of like rule based, or how were you detecting that? Because we have a lot of problem with like, every time we try to detect water, like shadow comes up, so
yes. Yeah, it's actually we used that's why you can use normalized digital water index as well. That's what I used for the water unmapped and change detection. So the project. So I think it's beneficial. So I create as well customized brightness as well, and the ratio of green is very it's worth to use it as well. And so just to distinguish not like from the water, but maybe from the green areas and the shadow, to capture shadow, because there is a height. Or in some cases I used because I run the change detection project for a couple of years already for different occasions. We had a project I did project for South Dublin County Council as well. But I used what I used is, I lost my point at the moment. But I used sorry, I just
no, that's fine. I have another question on top of that. Sorry, Jenny.
No,
That's okay.
Sorry, I used the height as well. Height and slope. That's what I was going to say. Slope is very good as well.
Okay.
So it's you can use the slope parameters as a layer kind of. Yeah.
Perfect. Another question. So in our change detection work at like in-house here, our task is to do the land cover, like kind of like change detection between two images. So we have like, okay, let's say blue sky image from 2010, blue sky image from 2015. And because these are not satellite images, you know, the brightness are different, things like that. So are you doing some kind of normalization before you were starting the process?
I actually for the change, no, I didn't use that. And we use actually, I for some of the change detection, I used the satellite imageries as well, but I didn't use normalize this. But I just help myself with the parameters within eCognition, like as I said, ratio of green, or the customized brightness, or what was that, and then the height values as well. Sometimes there is a cloud cover, so it's very easy to extract the clouds as well, just to capture clouds because of the heights. But so no, I didn't normalize that for my project. Yeah,
No,
but
perfect. Thank you so much.
Yeah, sorry.
Thanks, Zita. Thanks, Joanna. We'll move on now to Lorraine. So if you could stop sharing, Joanna, we'll get Lorraine's presentation up. Thank you.
Oh my God, just okay. I am now here. Sorry, I just have to stop sharing. Thank you.
Thank you.
Thanks.
Are you right there, Lorraine? So you can put any questions in the chat as we go along, and we'll come to them at the end of the talk, and just so you don't forget them as we go along. Okay, over to you, Lorraine.
So hopefully that's sharing okay.
Yeah, looks great. Yeah.
Great. So I'm Lorraine Barry. I'm a transport planner and modeler within the Department for Infrastructure, which has authority for transport and infrastructure in Northern Ireland. It's the government department with that purpose. And I'd also describe myself as a GI scientist as well as a transport planner and modeler, because my background is solely within the geospatial industry. All right, just 1 second. Okay. So just to give you a little bit of background to me and my roots and where I've come from. So I completed my undergraduate degree within geography at Queen's University, Belfast, and this is the geography building. If any of you are familiar with Queen's University, this is the classic geography building behind the Students' Union, located on Elmwood Avenue. And this was really my first introduction to GIS. Back then, it was in really early versions of GIS, ArcView 3.2, and early versions of 8.0. So that really began my fondness for this field of work. And I was fortunate enough to be able to complete my degree alongside French. So I undertook my undergraduate degree in geography with extended studies in Europe. And that allowed me to spend a year within Grenoble in the French Alps, which was absolutely fantastic opportunity. I learned a lot about France, about the city itself, and obviously, as I was completing about 8 hours of geography lectures each day, then I obviously progressed my knowledge within geography, all whilst learning in French. And I got the opportunity to learn how to ski as well. And whilst I was there, this built upon my knowledge of GIS, or SIG as it's known in France, Système d'Information Géographique. And I was building upon my knowledge in map info, albeit in the French language and with French pull down menus. And I was able to also undertake other modules, like to learn about the fantastic geomorphology of the region, Grenoble being surrounded by mountains and the Alps, and also undertook other modules such as Corem, which is a kind of a stylized, simplified version of maps and graphics, as you can see there on the screen. After my primary degree, I went on to undertake a master's degree at the University of Leeds, and this was an MA in GIS for business and service planning. And I chose this specifically for the dedicated modules in geodemographics and neighbourhood analysis, and also that programming, that capability and skills that lies at the University of Leeds. I undertook my dissertation at Leeds in geodemographics, and at that time it was still rudimentary IT facilities in that time frame. So most of my dissertation, or all of it, was saved on floppy disks, and there was no access to Teams, SharePoints as we do have now. Shortly after finishing my master's degree, I joined Queen's University Belfast as a member of staff and a GI scientist. This was after a short stint working in GIS for NI Water and water utility company. And I spent 13 years working as a GI scientist at Queen's University Belfast, and I had fantastic opportunities to undertake fieldwork throughout Europe. I spent a month in northern Norway surveying with differential GPS on glaciers right above the Arctic Circle to monitor and to report on movement of glaciers. I got the opportunity while I was a research scientist as well at Queen's in GIS to put together modules, to create content, to teach and instruct on GIS, and I've just pulled out a few examples of those. So this was both for geography, the School of Natural Built Environment, but there was also teaching across disciplines. So there was contribution to modules on climate change, for example, as you can see here with the School of Biological Sciences. And I also got the opportunity to work on modules such as Geography at Work, which was linked to industry and partners beyond as well. I got the opportunity to be involved in many great research projects. I've pulled out one in particular, so the web map is available to look at should you wish to. And it is a project which built upon taxation records to build a proxy of population of Great Britain for the year 1290. As I said, built on those crop, grain and taxation records. And I was actually fortunate enough to build this spatial analysis on quite a variety of wide resources and largely paper records, to build that into this web research and to produce a publication and a book chapter from the work and the project as well. Just to pull out a few other examples of some of my work at the time that I spent at Queen's University. So I was involved in many open data challenges. I contributed much work and showcases to Open Data NI. I created public workshops as well as student workshops as part of the science festivals, and I was heavily involved in open geospatial work as well, particularly within the field of Python. Throughout my times at Queen's, I also built upon my professional memberships. So I've been chartered with the Royal Geographical Society since 2017, and each year I submit a portfolio of evidence that I work towards both internally and externally in relation to geospatial work throughout the year. And a certain percentage of that is external beyond my job. I'm also a member of the Association of Geographical Information, and I'm a committee member of the local branch for Northern Ireland, so the AGINI, and I've been a part of that since 2017. And each year we organise a GIS conference. It was held last year at Queen's University Belfast within Riddle Hall, a really beautiful setting. It's scheduled, and this is my shameless plug, it's scheduled for the 12th of June this year. The theme is going to be really about interoperability across borders in terms of data, in terms of membership, in terms of organisations. So please feel free, reach out and attend if you would like to. We try to keep the costs really low in it so that as much people as possible can attend. So watch out just on our comms if you are interested. And I'm also working towards transport planning professional TPP, which is through the CIHT, the Chartered Institute of Highways and Transportation, and the Transport Planning Society. So that's in relation to my current role within DFI, the Department for Infrastructure. Whilst I was at Queen's, I had the opportunity to undertake a part-time PhD. So I undertook the part-time PhD over a number of years whilst working full-time. And my topic of research was in GIS, in geographical data science, and more specifically in spatial interaction modelling. So looking at that, looking at the patterns of movements and flows in relation to underlying tendencies between origins and destinations. And the basis of my PhD was on the journey to work census data from census 2011, where respondents to the census are asked the question, where do you live, where do you work? And that data is made available for research in terms of that origin and destination for journey to work and journey to education also. So whilst the research has many different facets, quite often it's the visualization aspect of my research which comes to the fore since then, and it's just really I've pulled out a few of the outputs which are drawn upon again and again, particularly within my job role within the Department for Infrastructure. So this just looks at visualizing, purely visualizing without any analysis, just the movements from centroids of population centroids within census boundaries, and how those movements reflect across Northern Ireland for that census period in 2011. So you can really see those hinterlands and catchments of urban areas and the power of influence to the east of the province, particularly the draw to Belfast as a large economic centre. And from that research, I was also able to pull out some of the headline figures. So, for instance, I observed that almost 70% of travel in relation to commuter movements, journey to work, was internal to the east of the province, 22% to the west of the province, and only 8% crossed east to west across that boundary of the river ban. So it's quite often those visualizations that have remained prevalent since the research was published. And this really ties me in, this research, into what I'm doing today. So I've just pulled out how we use similar data within the organisation today. This is an example of TomTom data, and we utilise this kind of data on a daily basis to analyse flows from origin to destination on a wider scale with a much larger input of data. So as I said, this is based on TomTom data. It's millions of points of movement points linked to car in-dash navigation systems, portable navigation devices, and anonymous GPS-equipped mobile phone data, which is all collated and anonymized, obviously, and provided through TomTom. So we rely on this data to have kind of a picture of movement across the province at different timescales. That's just another view on that origin destination data from TomTom, and also just a different visualization. This is a Sankey diagram which shows it's a really nice and interactive way. This is obviously a static screenshot, but actually the data, when you hover over it, it's animated and it moves, and it's very visual. So just to bring you up to kind of current day, I work as a transport planner and modeler role within the Department for Infrastructure. I moved to the department within 2017, and it was my work on my PhD in that modelling movements that brought me into this job role and into the field that I'm working in today. And really, my role for the last number of years has been working on the production of a suite of transport plans, and in particular, the Eastern Transport Plan, which covers 5 councils to the east of Northern Ireland. Really, the Eastern Transport Plan looks at a framework for making policy decisions and investments up to 2035, and it looks at the existing network and the future network. And really, the Eastern Transport Plan and any of the transport plans that are being produced feed into the statutory requirements of local development plans for each of the councils within Northern Ireland. So that provides us with the basis for our work as well. And just to look at some of the transport planning and modelling tools that we would use. So some of the tools are related to forecasting, looking at for example, Tempro, which is a spatial tool for forecasting employment and population in the future. We have strategic transport models at hand to model measures and proposals for the future, and they're all spatially based models. We have local transport models, which again are spatial too, and those would be used for more junction level changes and details at particular very localized levels. And then we also have increasingly a range of supporting analytical tools, which are largely GIS based. So I've taken just a few examples at the bottom of the screen. So the first is Track. It's a GIS based piece of software which does a few tasks, but does them really well. And really the task is around network analysis and that creation of catchments in relation to different modes of transport, be that walk, cycle or vehicular. And I'll talk a little bit about some of the outputs from that after. The second there is, as I spoke about, is that access to portal-based applications which provide more data and insight in relation to origins, destinations and movements. And thirdly on the screen there is INRIX, which is a provider of visual data, spatial data in relation to networks, and average speed data. So it's average speeds across the network. So in distinction to speed limits, this is the actual average speed, which gives us an indication of congestion across the network as well. So just to look at by no means conclusive list of transport planning and modelling data sets. This is just a flavour. It's quite wide and varied. So we obviously utilise a walk and cycle network, and we look at cycle infrastructure such as cycle parking. We look at the public transport network, the road network, crossings and pavements, parking, including blue badge, coach and taxis, and that's huge. There's potentially lots of discussion and overlap there with the likes of automatic detection from Earth observation in relation to the car park. The car parking and the amount of car parking that we have. And we look at origin destination data, cordon counts, which is the movement of all modes of transport across a certain cordon line, be that by bus, car, walking, cycling. We have access to speed data. Demographic data is really important as well, planning and land use data, and that input from the councils as well on that planning and land use, particularly in relation to growth and projected growth in the future as part of local development planning. And increasingly, sensors and Earth observation data is becoming more and more important to our field of work. So that ability to monitor movements at an anonymized level via sensors is extremely important to know the volume of pedestrians that are crossing certain streets and moving around is more and more important to our field of work. Just to give you a flavour of some of the work that we've done in the past and we continue to do, we produced a few years back a guide on, and this is available on the Department for Infrastructure website, a guide on accessibility analysis, which sets out some of the method and parameters for creating catchments in relation to accessibility for different modes of travel. And this is a guide that we use ourselves, but it's also used by councils and other organisations to undertake this type of analysis work, and it's accompanied by a toolkit data set as well. And on the right there you can see an output for network analysis, accessibility catchments for travel time by public transport right throughout Northern Ireland, and you have the times indicated then as well. And this type of analysis is based on not distance, it's not based on the road network, it's based on public transport timetable data, and it's linked to those timetables. This is a second example. So this just shows similarly public transport accessibility travel times across the Belfast City Council region during AM peak hour. So again, it's based on public transport timetable data, and really this is illustrating how demographics can be built into this type of analysis as well. So by combining census data sets from 2021 census, we can observe that in this case, in this example for this council, that over 96% of households can travel to the city centre within 30 minutes by public transport, and over 98% of Belfast residents aged over 65 can access the city within 30 minutes by public transport. So obviously that's really high accessibility by public transport, which is good, but that's not the picture for all councils throughout Northern Ireland. So it's something that we like to evaluate and use as part of our transport planning. Again, on the left-hand side, we've got a picture of accessibility, but this time it's 30-minute cycle time throughout the Belfast urban area. And on the right-hand side, I've taken a picture of this accessibility. The example is from 3 strategic employment locations, and within that guidance, we provide recommendations for how to rank or assess the accessibility to such strategic employment locations. So of the 3 presented, 1 presents as with poor accessibility, 1 with fair, and 1 with good. And you'll see there in the centre of the screen, strategic employment location site 2 presents as good accessibility because there are over 330,000 residents who can access that site within 60 minutes by public transport. And if we look further across at the table, there are, I think it's 5,500 who can access that site within 20 minutes. So really, it's just a really efficient way to measure and evaluate public transport accessibility to sites, and this is really key within that integration between land use and transport planning, and the promotion of the priorities of the Department of Infrastructure to lead on sustainable transport and associated land use with that.
Lorraine, this is fascinating, and I hate to interrupt you, but we're coming up to the time. So if you want to maybe just go to any messages, last messages.
Yeah, no problem. Thank you.
Thanks.
Yeah, just an overview of how we use transport models and why we use them, and look at how we can evaluate packages of transport project scenarios. And some of the inputs for transport models, we have trip-bound models, we have demand models. We go through process of we assign those to both the highway, and we undertake public transport assignment, and our outputs are all very spatial. So we look at flows across the network, we look at differences between scenarios of doing something and doing a minimum, and we can look at select link analysis as well. Thank you, and hopefully I've left a few minutes for some questions.
That was fantastic. Thank you so much. And the visualizations are just stunning. Really, some of those, they're just so visual, so visually arresting. Joanna, you have a question? Come on in.
Yeah, hi, Lorraine. It was very interesting. Yeah, thank you for that presentation. And it's coincidence. I actually did my master in geocomputation about the geodemographics as well, and about visualizations.
We have a similar background.
And I worked on the radio. It was RStudio, and then Python I used on the land cover project as a researcher, scientific researcher. But yeah, it's great to be able to visualize in different ways. It's good. Yeah, it's brilliant. It's telling much more than the text. So yeah, sometimes. Yeah, but it was great. Yeah, thank you for that.
Thank you.
Is there anybody else out there? We're about a minute past 2 o'clock, and so this is intended to be a lunchtime webinar. We tend not to go too far over 2 o'clock so people can get back to their day jobs. I don't see any hands up, but if you do come up with any questions, I have a lot of questions, but they're mostly around what would that information look like for the city I live in, which is Galway, which is a very famous traffic issue. Yeah, maybe we can talk about that another day. Thank you both very much for joining us today, Lorraine and Joanna. And just to remind people, the 2nd of April is the next webinar in the series. And as I said, we'll be talking about early careers. We'll have some helpful information and pointers for people who are early on in their careers. And it's open to everybody. You'll probably learn something even if you're not early in your career. So do come along next month and we'll have some special speakers and a kind of a panel discussion around that. So thank you very much, Lorraine and Joanna, and thanks everybody for joining us today. The talks will be up on the YouTube channel of which you can find from the LinkedIn page of the Erogi Women in Geospatial Irish chapter. And we'll see you all next month, hopefully.
Yeah. Thank you very much.
Enjoy the rest of your
Thank
Wednesday.
you.
Bye. Thank you.
Bye.
Bye now.